Hello. I just wanted to give a quick warning to anyone who's still following along with the videos and scripting along with me. Congratulations, by the way, for sticking it out this long. We're getting there, but there's still quite a bit that we have to do. The warning is that I will be reverting much of the logic that I add in this video. So a lot of it will be staying, but there is quite a bit of it that I will be changing or deleting in the next video. So most of the stuff that I'll be deleting is the logic contained in the top level of the event graph of the timer bar blueprint. And that's because in this video, I try to do the timer bar's logic without the column checker objects, but I end up realizing that I do need those to do it cleanly. So I add those back in better in the next video. But in this video, I try this thing with a Boolean value to keep track of whether I'm inside a column of blocks or outside a column of blocks, and that ends up not panning out. But the other stuff in this video is going to stay, and it's pretty important. So I would still follow along and see if you can predict what I'm going to end up changing and what I'm going to keep. But stuff about ignoring the player's quad and a few other things are going to stay. So stuff in the DropAll blocks function that I'm editing will stay. So I would still say follow along, and if I'm doing stuff that seems weird in the timer bar event graph at the top level, you can just watch and then or skip past that, and then you'll see the proper way that I fix things up in the next videos. So let's go ahead and get back into it, and thanks for watching this far, and hopefully you'll stick with it. I don't want to, paper over the somewhat sloppy implementation of these column checker objects, so I have another idea for how to do the same thing, and I'm going to go ahead and try to do that right now. And if it works, then I can remove this entire class of objects. But for now, I'm going to try something else. So instead of having those overlap with the timer bar and just, put it in between, because that's just asking for confusion later on. Be like, why did I do it that way? What was I thinking putting the bar at some weird offset between the two objects so the bar hit both of them, but they didn't hit each other? It's a little bit weird. I don't think I should do it that way. So I'm gonna remove that. That's it's just a bit unintuitive, I think. So what's this for? Well, it's gone now. And now I'm going to do it the other way. So now we have the timer bar. Instead of checking for these column checker objects and then using their location to scan the column, I'm going to remove this and remove all of this branch entirely. So for now, I'm just going to do that and this and move this down here. But in the future, if my new idea works, I'm going to remove all this stuff right here. And we're going to have a on-component end overlap. So right now this is a on-component begin overlap timer bar mesh. We can add an event here for on-component end overlap. And if the other actor that we're stopping the overlap with, if that is of type block, then what we're going to have to do is add a variable here called the checking for matched blocks. So the purpose of this Boolean is to make it so we only run this function, scan column, once per column. So because what this does is does the ray trace, that we only need to do that once per column every cycle. So it's going to initially be false, and as soon as we find a block in this column, whether it's matched or not, every time we overlap a block, we're just going to set be checking for matched blocks to true. And that's when we begin overlapping with a block. And now when we the first time, if that is true, if this is currently true, that means we were in the process of scanning all the blocks in that column. Up to 10 blocks could be in that column, and we'll hit them all at the same time, and then this event will run 10 times in very quick succession for each thing we overlapped, and this will be set to true. And then when we leave the blocks, when the timer bar leaves the block collision zone, which is like in the middle of the slot here, it's going to leave all 10 at once, but we only want to run this function once. So we say, if this is true, that means we've just left, and this is the first time this event is running and we're leaving. Then we set this to false. If true, we set this value to false, and then we do this other thing, which is we run scan column for blocks. And now we need some sort of counter, so we'll need a integer counter, and it will be current column, and it's going to increment starting at 1, so that we have, or I guess starting at 0. So that means it'll be a post increment, so it's going to run this function. It'll run this function, and then it will increment. Now it's a type integer. We're going to post increment this. So, and by post I mean after we run the function that it matters for. And we're going to use this counter to set this start location. So we'll do vector plus vector. And the starting vector is going to be the grid location, so we get the origin of the grid. And then the offset from the origin of the grid is going to be horizontal offset times current column plus a plus 1/2 of horizontal offset, because we need to go from the grid lines to the centers of the columns. Offset divided by 2 is half of an offset is what we're always going to have, at least half an offset, and we might have more offsets based on what the current column is. And that's going to be our horizontal offset from the grid origin. And that's what we feed into here, which should be the same value as what we were doing before. And then we increment after we do that, so that the counter remains accurate. And then we need to take care to reset the counter when we're going to move back to the start of the grid. So I don't think it matters if I do it here or there. I'm going to do it here. I'm going to make a comment right here and just say reset counter to 0. That way, looking back at this in the future, no one will be confused and think that I was supposed to hook up a wire to this node, this pin, because it's got a comment. Because by default, any time you set the pin to something, 0 is there by default. So I want to make a comment to let future self know that I intended to leave this as 0. And this should do the same thing. And then we can get rid of the column checker objects. Oh, maybe I need to move the timer bar back to,
Okay, that's what's happening. Okay, yeah, it's not the counter isn't incrementing when there aren't any blocks in a column. So the timer bar is moving through columns that are empty, and obviously the counter isn't being incremented, so it's not representing the proper column that we're in. So I can fix that in several ways. I can not use the counter at all, and instead, when I set this to false, I can just get the location of the current blocks that we're in and use that as the X value of this offset. So that'll simplify things slightly here, because I won't have to do any of this or this. But it's a little bit, I guess it's actually just as good as this is. There's nothing better about this idea. So I don't need this counter, which means I don't need to worry about resetting it here. I may in fact need a counter for something else at a later date, but right now all I need it for is what I was doing before, which I don't need it for anymore. So now what I'm going to do is, when we run this function, we get the block that we just stopped touching and get its X location, get actor location, and that will be centered in the row, in the column, because it is itself centered in the column. So we can just split this and get the X value of it. We don't even need to offset from the grid, really. We just get the X value, because this is in world space, right? So this would actually introduce an issue if we did this. So we could just we could just do this. No. We do need to, we can get the X value from the block, but we don't want to get the Y or the Z value from the block, because this block could be any elevation, and we want to make sure we start at the bottom of the grid. So we do need the grid in order to get the, we can go ahead and make vector here and connect it to here. We want the Y and Z values from the grid. And the X value from the, I guess we get the Y value from either one because they're going to be the same, but that's fine. That should do it, because we'll get the horizontal offset into the grid from where the block is located, and the Y and Z will come from the grid origin. And that should be good. Yep, that seems to be working. The reason why this went off is because I had the quad hovering over here, which was an expected error. The quad still needs to be dealt with, so that we don't, do things to the quad that we shouldn't be doing. But for now, I want to see if the function spits out any values. Yep, there we go. So it spat out these two values, and it seems to have spat them in the correct order. But to verify that, I need a few more samples. So let's see if these, it should have been, so if the algorithm is working as I expect it to, it should be this one, and then this one, and then finally this one. So it should be the one with the lowest X value, and then this one, and then this one, and then this one. That seems to be outputting them in the right order. So if you look at 650, 550, that's that is this block. You can check its location right here, 650, 550, and then this block is 750, 550. and this block is 850, 250, and then this block is 850, 350. So it's following the order from our algorithm here, where it goes bottom left of the relevant blocks to the top right of the relevant blocks. And when I say top right, I mean the highest in the rightmost column. And when I say bottom left, I mean the lowest in the leftmost column, not necessarily the bottom left of all of the 4 blocks. But hopefully that's clear, and it does seem to be working as intended, except for the fact that it's scanning these quad block elements. So we can go ahead and fix that now before it drives me crazy. What we can also do is delete all of these 16 column checker objects. I just selected 17 things, so make sure I deselect the level and the camera, so I only have the 16 column checkers selected, and then I can delete them. And then I may not be able to delete the class. Well, first I need to delete all references to it, so I can remove the box component. So it's just an empty blueprint basically. And then I need to remove the references to it within this blueprint here. Just remove everything here. And then I may or may not be able to delete this right now based on what the editor decides to let me do. So if I press delete, there are no memory references to this object, so it'll let me delete it. But sometimes you go to delete something that you don't need anymore, but you were utilizing it heavily recently, and so there'll be references in memory, and you'll have to, close the editor and open it back up and hope that those memory references are gone, and then delete the object or the blueprint. So now let's move on to preventing the scan columns function from using the current quad. So we go into scan column for blocks, and if the block that we are currently looking at, before we check anything about it, we want to make sure it's not one of the 4 elements of the quad. So we can get game mode, and then we can get quad elements, and we want to make sure that this actor is not one of these 4 actors, but we do need to cast it to a block first. So I'll expand this comment block a little bit, move this over, move this over. I want to say not equal to. I'm just going to get the 4 quad elements explicitly so that I can do a big and statement here, Boolean and, without having to do a big loop or whatever. We want to ensure that the current block is not this object and is not this object. That's not pretty, but I think the rest of the logic is lined up clear enough that hopefully the wires crossing is not too bad. I'm just going to put a little comment here that says, make sure that we ignore the quad that the player is controlling. I realize now this could be done probably a lot more simply by just, it's true that they say hindsight is 20/20, but luckily it's not too late to do this. If I could just say get quad elements, run this function, and put the quad elements here as the array of actors to ignore, and then it will ignore these elements. I think that's probably more efficient, because if we do it like this, we will be running, you know, this big compound and statement for every element of the loop that we loop through. So yeah, this is probably not the best way to do it. But I am going to leave it there just in case the other way that I just tried doesn't work. So then we have them to fall back on. But I think this should work. And I'm just going to copy this little comment here, even though it's a little bit more self-documenting in this format than in this format, I think. So now we shouldn't see those ray traces when the timer bar passes through the quad, but we're still seeing them. We may need to nip it in the bud earlier on in the process. What I mean is the timer bar is overlapping quad blocks and treating them as blocks. That should make it start the process of doing its whole scanning. So on begin overlap is where we should nip this problem in the bud by saying make sure this object is valid and is a block and is not the quad, right? So I should probably make a little helper function in game mode, say like, is this block part of the quad? So this function is going to do exactly what it says. It takes in a reference to a block, and it returns a is part, is quad member. Or is quad element. So we stay a little bit more consistent. Maybe this is where I will get to use the logic that I painstakingly created here in the scan column. So like, you know, we can do this kind of, except we still have to change it. So it's still not really the same thing, but we can put this in here. We just have the 4 quad elements here. And this return value should be a Boolean. And so if it is not quad TL and is not quad TR and it is not quad BL and it is not quad BR, that means it is not a member of quad. So I can maybe reverse these and say, you know, I'm going to like double negative it if I want this to return yes for if it is, right? So it's not, and it's not, and it's not, and it's not. So if it is this, or it is this, or it is this, or it is that. Hopefully you're familiar with the basics of ands and ors in Boolean logic. It's not that hard to explain, and it's not that hard to understand, but it is certainly takes some effort to learn it the first time if you're unfamiliar with it. But at some point you'll get familiar with it, so you don't really have to think about if what you're doing is correct. You just have to, do it. And I'm going to say it like I know what I'm talking about, and yet my logic is probably going to end up being backwards. So we're saying if the object we feed into this function is any of these four, so if it's this one, or if it's this one, or if it's this one, or if it's this one, then we return true from this function. And only in the case where all four of these fail, so like it is not quad TL, and it is not quad TR, and it is not BL, and it is not BR, then this OR block will output false, and which means we'll return false from the function. And in the case of timer bar, when we call the is block, part of quad, we want it to be false in order to do the logic, so we're going to have to invert the output. So in order to carry through with the significant logic over here, the function needs to return false. So we're going to say game mode, is this block part of quad? When you call a function, you have to use the execute pin, so that's why I need to put this on top. And I'll shift these down one slot so I can put the output here. And I need to invert this. I'm going to say not Boolean, which will invert the output of this and then shove it into here. So all three of these need to return true for the and to return true in order for the logic here to carry out. So at the end of the day, this is doing the same thing that I set it to do when I put it here, but I no longer need it here because I'm going to catch it before it even gets to this point. Maybe I do need it here too, but if I do, it's here. So hopefully you were able to follow along with that and weren't confused or bored to tears. If you're bored to tears, then you've probably stopped watching long ago, and I don't begrudge you for that at all. So now we want to move this up and move these down. Perfect. So when the timer bar begins overlapping a block, we also need to put this on the exit too, just so that we don't call functions prematurely. So when we begin overlapping a block, we want to make sure it's not a part of the quad. In addition to what we were doing before, make sure it is a block and that it's not part of the quad. And this block here needs an input, so it needs to actually be... Oh, that's that throws a little wrench in this. We need to separate this logic. So, whoops, I need to remove this pin here, move this back to how I had it originally, and I need to make sure the block is not part of the quad after I've already confirmed that it is in fact a block. Otherwise I won't be able to feed it into this function because it needs to be a block. Just making room for the logic here. So once we've confirmed that we are overlapping a block, we make sure it is not part of the player-controlled quad. And if it is not part of the player-controlled quad, then we check its state to see if it, here's where we could combine these with an AND, but I'm not going to do that at this point. It's fine. So that should be good now on this end. Now on the other end, when we stop overlapping, I'm just going to move this over. We need to cast this to block BP. And then we need to make sure it's not part of the quad. And Boolean. Okay, that's that. Now let's see if the player's quad is ignored in these checks. Yes, it seems to be immune to the timer bar, which is what we want. So one step closer to completion. Now we need to make the individual blocks fall all the way down when it is their turn to do so. So we can make a function in the individual blocks drop as far as possible. Now there are two ways that we could do this, at least that I can see. We can have them, if we want the block to immediately fall to its target position, we can either do a while loop that checks one slot below the current slot where the block is, and if it's empty it'll drop down, and it'll just keep doing that while loop until it's not empty, and then it will stop falling. Or we can do a ray trace one entire grid height down, so regardless of whether we're here, if the current block is halfway down the grid or all the way down the grid, we just do a ray trace one grid length down until we hit the bottom of the grid and we find how far we are from the next object and then drop down that many spaces. But that'll involve, if we're here and the next block is here, the ray trace will, it will be some number that's not a clean grid offset because of the fact that the collision boxes are not directly aligned with the grid offsets. So we'll have to do a bit of manipulation of the result of this ray trace to find out how many spaces we need to move down. That should work fine, but I'm going to do it first way I said, where I'm going to just move down one slot at a time until we stop, because that's going to be more similar logic to what we currently have in the player controller for check move down. We just look one slot below us, and if it's a empty spot, then we move down, and if it's non-empty, we stop moving. So I'm going to do something like that, so it's just more similar. So copy all this, but we don't need this, and we don't need that. We do need that, but we'll get it from game mode. We don't need this array because it's taking place in the block itself. So we copy everything that I've highlighted here. We should just be able to copy this into the block BP's version of this function. We have our own game mode reference, so this will be fine. This gets our location, which is what we want. We need to make the object types so that's E object types. One element world dynamic. Ignore self. If the thing we hit is either a grid BP or block BP, then we're going to end the while loop. And if it's not, we're going to just end this iteration of the while loop and continue on. So let's add the while here. So this is the loop body. The conditional is whether we're gonna, let's call it B keep looping. So, or that's a bit bad. So I'm gonna rename that to B can fall. It is not an array and it is of type Boolean. So while we can fall, which this needs to initially be true, so we have to set the default value to true. While we can fall, we're going to just keep falling, one spot at a time. If the thing below us is one of these two things, then we have to set can fall to false because we've stopped falling. Otherwise, we just do nothing and it will stay true. And then on complete, we just can return from the function. We're at our new location already. Well, we need to actually update our location. That's not happening in this function because we copied this from check move down, and then it returns, and then at the higher level, we actually move down one space. So we have to kind of concatenate both of these into one function in the block. I just realized this is horizontal offset here. It should be vertical because we're moving down in all of these functions. So let's check left half, right half, both have horizontal here. Let's see if that's the only place where we're actually moving them down. So we need to just change these to vertical offset or get vertical offset. We didn't notice an issue yet because our grid is made up of squares, but if for some reason our grid was made up of non-square rectangles, we want them to be the accurate variable here. So that was move left. Now we just got to do the same thing here. And now we just copy one of these. We can exclude that part and just take this part, bring it into here. Now yes, this is like code duplication, but it's doing something a little different. It's wrapped around the while loop instead, so I think it's fine to just have a tiny bit of duplication like this for now. And we can use the same call to vertical offset if we really want to. this is also not correct. We want to actually move it down within the loop so that we do it multiple times. So we don't want this here, we instead want it here. So now when we call this function on the blocks one at a time, they'll all fall to their destinations in order. So let's do that. We call DropAll blocks to fill gaps, and for each block that is in our blocks array, we no longer need to get the space. We verified they're in the right order. Now we just need to call drop as far as possible on each block, and we should get the desired behavior now. We're still not destroying the matched blocks when the timer bar clears the area. Once we have found a column with no highlighted blocks, then we need to do something. We need to tell the game mode to, well, we need to clear all the highlighted blocks that we currently have. We don't have an array of those yet. We're not keeping track of the highlighted blocks. So when we find a highlighted block, or when we ourselves highlight a block, right here, when the timer bar tells the block that we just touched to become highlighted, we need to keep track of a highlighted array. Now this, it doesn't really matter what order they're in, but it should be in, it's going to be in whatever order the overlap events happen to trigger in, which there should be like at the same frame, but it could be a arbitrary order. It doesn't matter in our case. We're going to add this block we just highlighted to this array. That's all we need to do here. And then when you were leaving a column and we haven't highlighted anything in this column, that's when we need to destroy all of the highlighted blocks and then call DropAll blocks. So we have that set up here in the scan column for blocks function of the timer bar. If we've looked through this column that we're currently located in, and we did not find a highlighted block in this column, then we need to tell the game mode to drop all blocks to fill gaps. But first we have to actually create those gaps by destroying everything that is in the highlighted array. Now we may run into a strange condition here where we tell all these blocks to destroy themselves, so we'll say for each loop here. This will be uncompleted if we do the next step, which is to tell the game mode to drop all the blocks. But for now we need to actually destroy these highlighted blocks. So each one just destroy actor, which will destroy itself. But destroy doesn't happen, immediately. So it'll happen at the end of this tick, at the end of this frame. But when we run drop all blocks to fill gaps, we'll see what happens. There may be an issue where the blocks don't fall all the way because they run into a highlighted block, so we'll need to account for that. Like the blocks that are above the highlighted should drop through the empty gaps. The gap isn't there yet because these blocks are still pending destroy, so there'll be an issue, but we'll see what happens. Okay, so it seems like the blocks dropped appropriately. Let's test it a few more times to make sure. Okay, yeah, I'm not resetting a boolean somewhere, so it's only happening once. Or it's only happening when there is blocks past the ones that need to drop. So see, that one worked because there was this column of blocks here after the last highlighted block. But if it's empty after the last highlighted block, it's not calling the functions properly. So this one should work. But if I were to make a match like here and then here, I don't think these ones are going to fall because the highlighted blocks line up with the very last extant blocks. So it's going to just move past them and then not clear these ones until it reaches this block right here. And it's like, okay, this column doesn't have any highlighted blocks, so then clear. But, okay, here we're also getting the errors saying, pending kill 1,000 times because we're not accounting for that. So we got a couple errors to work through here. Okay, so one of the several issues is I need to clear the highlighted array after I destroy all the actors in it. Otherwise, the next time I call that function, it could be, since it's not a local variable, it's going to persist and it's going to have null values in it, or hanging pointers. It's going to be it's bad news. We need to just clear it. And then when we drop all blocks, we use blocks array to do that. But we're not checking to make sure what we're dropping is valid, so we should do that too. But before we do that, we need to, in this function, we need to make sure that the blocks that we look at when we do our check are not highlighted blocks. If they are highlighted blocks, we want to follow through them. And what may be happening, let's see. First, let's see what happens if I fix what I just fixed. Let's see if there's still a bunch of errors. That behavior won't happen if the underlying problem is fixed. The behavior we just saw here where 2 blocks got cleared by themselves. So let's see what errors we still have now. No errors. And the case where the blocks... yeah, this is still the underlying problem. So let's fix this problem and then diagnose any existing problems after that. Now the next problem we want to tackle is if the timer bar passes through an entire empty column, then there's no blocks there, then it's not going to ever trigger the this will never scan the column. So now is when I start to wonder, hey, maybe those column checker objects weren't such a bad idea after all, and we just implemented it poorly. If we want to replicate the actual Lumines gameplay mechanics as closely as possible, we need to make some refinements and changes to the way the mechanics in our project currently work. So in the real game Lumines, the timer bar is sort of preemptive, like it looks, as soon as it enters a grid column, like right here on this first line, it checks the column to the right, and if there is a highlighted block, it starts highlighting them as it moves across. And as soon as it gets to a column as soon as it gets to a line column, like right here, where there are no highlighted blocks to the right, it will immediately destroy the blocks to the left that were just previously highlighted. So we need to get the box inside the collision box. We need to make the collision box inside of these blocks almost exactly the same size. So we need to scale this up a little bit. Or 1.4 is probably good too, 1.45. My primary concern was doing diagonal checks and hitting the wrong blocks when we do that, so I want to make sure it's not quite going to touch the ones above and below it. So let's see how that works. Doesn't seem to have broken the highlighting functionality or the matching functionality by increasing the box collision size. This is unexpected. So here we have DropAll blocks to fill gaps where the block below us is pending kill. So this is one of the issues. It seems to be like a race condition, so it's not going to happen every time. But we want to obviously fix that. So when the blocks drop as far as possible, we want to make sure the block below us is not pending kill. And if it is, then we don't count that as something that's stopping us from falling, because that means it's a highlighted block, which means it's going to not be there in a minute, so we want to move through it. So I'm going to refactor some of this just to give myself some peace of mind. And to keep it simpler, I'm going to do just the grid first. So if we overlap with the grid, we're always going to stop. If it wasn't the grid, then maybe it was, is valid. Okay, so if it's valid, then we're going to try to cast it to the block class. And if we can cast it to the block class, get my state. So if it's not highlighted, then we must stop falling. This might look confusing, but hopefully it'll make sense in a moment. If what we just checked was a block and is not highlighted, that means we must stop falling because it's a matched or unmatched block, so it's still solid. But if it is highlighted, we'll continue falling. If we can't cast to a block, then we should keep falling. So let me see if we still have the issue where blocks don't fall through when they should. Yeah, the blocks just don't fall for some reason. Oh, you know why this case is? I think this won't be an issue, I think, later, because those blocks aren't being added to the blocks array because they were placed on top of highlighted blocks. I'm going to restore the scale here. I think part of the problem could have been the scale was so big that the timer bar was never reaching an instance where when it was no longer overlapping a cube. I think we do want new collision boxes, like here and here and here.